Okay, so we're back with part 2 of the tutorial, and you'll notice that I've got all of the data that I need here for this particular lab, and the data points still don't look like a whole lot. Okay, now I want to leave this in a scatter plot, but I'm going to change it for you just briefly, right? Actually, let's see here. Let's change chart type. And if I change it to line instead of scatter, now it actually looks like a wave, right? That's the kind of shape that I'm after, okay? So that should give you an idea of what the data actually look like. And we'll see why we want to keep that as scatter plots here in just a moment, okay? So, and actually, let's leave it as a line for just a moment, okay? So let's talk about the wave, and this is the spring bouncing up and down. This is actually the spring at the bottom, because you'll notice this is marked as the 70, and 70 is the bottom of the oscillation here, and 30 down here is the top of the oscillation as I let it move upward, right? So immediately, that should tell you something. You can immediately read off two of those parameters that we have on, actually I can expand this sheet now, right? So you can automatically read off two of these parameters, and those two parameters are the amplitude and the offset. So the amplitude is the height from equilibrium, and as you can see, the 50 centimeter mark really is the equilibrium position here, okay? And it goes upward 20 and then downward 20, upward 20 and then downward 20 from that position. So we can say automatically that the amplitude should be 20 and the offset should be 50, okay? So that automatically raises up the model line. And actually, now that we're here, let me change the chart type back to scatter, okay? There we go, that's what I want. So you actually have to click on a specific data set, but I'm going to change the model back to a line and leave the data as scatter. Now, your omega, okay, is going to be whatever, well, you can find it from the value of the period that you measured in part 1, right? So remember that the period is equal to 2 pi over omega, or likewise, omega is equal to 2 pi over the period. So whatever you measured for the period, you will be able to put in a specific omega. Now I'm just going to put in, now your omega can run from anything, okay? You can have a frequency from 0 up to infinity. Your omega does not matter. Your phi, however, has to run between 0 and 2 pi, okay? So I'm just going to throw in a generic omega here, okay? So let's just say an omega of 3. Now all of a sudden, that changes to a wave, right? That changes the model to a wave because it's automatically calculating it's automatically calculating positions based on the time here and then these parameters here in this equation, okay? And actually, now that I'm thinking about it, you might want to, okay? You might want to go back, oops, that's not what I wanted. Go back and actually change this to a scatter plot with the points with the connecting lines, so you can see how your model and your actual data are lining up, okay? So what you see here is if I just generically pick a frequency. Now, again, what I would do, okay, I don't want to give you any answers, but what I would do is actually start with the frequency found from the period in part 1, okay? That's where you want to start. So plug in that frequency here and see how things line up, all right? And then putting different values between 0 and 2 pi or 6.28 in that cell will cause the graph to shift. If I want to shift the graph to the left, I'm going to put in a positive number. If I want to shift the graph to the right, I'm going to put in a negative number. So technically this can actually run between negative 2 pi and 2 pi. Okay, so it's not just between 0 and 2 pi. It technically can run between negative 2 pi and 2 pi. But in any case, okay, so the thing to note here is notice that the frequency of my model obviously does not match the frequency of my wave. And the frequency of the wave seems to be higher, right? I'm passing about 2 crests on the model for each crest on, or I'm sorry, 2 crests on the data for every crest on the model. So that tells me that my frequency is too low. So based on your initial guess, you can play around with this and increase the frequency, and you can see what happens. And that looks a little bit better, right? And then you can shift the wave right or left to see how things line up. And you'll notice, okay, that the peaks are lined up pretty well here. They're a little bit offset here, a little bit more offset here, and then they kind of get even more offset until they almost line up again, right? So that tells you that your frequency is not quite right. The thing you want to do is to try and get the point where both of your peaks are about evenly spaced, and that will depend on your frequency, and then adjust the phase until the peaks actually line up. So for example, if I actually want this peak to line up with this peak, I'm going to put in a bit of a positive number here and shift the graph to the left, and that causes that peak to almost line up with that, but it offsets everything else. So that tells me that everything's not quite right. So the game here is to adjust these 2 parameters, the frequency and the phase, until your model matches as closely as possible the data, okay? And then you can read off the frequency that best fits the data. And you can compare that with the frequency that was calculated from just measuring the period itself in part 1. Okay, so I am going to upload some discussion questions as well, but I did want to show you guys what to do. Now, once again, I cannot stress this enough. Plug in your calculated value of omega from part 1 right here as your initial guess. Okay. And then more or less what you're really going to be doing is playing with your phi and adjusting that to try and get things lined up as close as possible, and then adjust the omega even further if necessary, right? But you want to get things lined up as close as possible between the blue data points and the orange solid line there, okay? So that is the game. That is what you are trying to do, okay? And hopefully this has made some sense with what you're supposed to do. If you do have any questions, do feel free to send me or your TAs another email, and we'll get you guys hopefully squared away. And I bid you guys happy physicsing and have a good week. We'll talk to you next time.